Okay, let's look at problem 2 uh, of exercise 6. So this is problem sheet 6, and we're looking at the second problem in that. So here we have said that we have EMG signals that are controlling the artificial hand, and we are saying one of the functions of the artificial hand is done when muscle 1 is activated, muscle 2 is not activated, and muscle 3 and muscle 4 are in the same state, either activated, both are activated, or both are not activated. Okay, so that's when the function is done. So we want to write a truth table for that. So that's problem 1, the first thing that we want to do. Okay, so of course, what are the inputs here to the system? I mean, uh, they are of course M1, M2, M3, M4, isn't it? So you can think of the system like this with 4 inputs: M1, M2, M3, M4, and one output, which is whatever, let's call it function F. Okay, so if you write a truth table here, so we get M1, M2, M3, M4, and you get 16 variants, and you have the output F. So let's fill in the truth table. So you have 0, 0, 0, 1, 2, 3, 4, 5. One of the things that you could do for your exam is you could probably keep these tables already done, maybe on Excel sheet or something, so that you can just quickly copy and paste and you don't have to spend time writing these out in your exam. But that's up to you. Okay, so those are the first 8 conditions. Okay, here's what we'll do. Let's just copy this entire thing. That's not working very well. Okay, let's copy this entire thing, and what I'm going to do is I'm going to try to get this on another slide so that we can fill this up. Okay, so I'll pause the recording, I'll copy it, and then start it again. Okay, so there we have the recording and starting again, and let's just fill this table up. 1 0 1 1 1 1 0 0. Sorry, that's supposed to be a 1 here, not a 0. 1 1 0 1 1 1 1 0 and 1 1 1 1. Okay, so that's our table, and we want to write F. Now when is F equal to 1? We said F is equal to 1 when all of these conditions are true. When M1 is activated, and let's say activated in our table means activated is denoted by 1, and non-activated is denoted by 0. Okay, so M1 should be 1, M2 should be 0, and M3, M4 should be the same. Okay, so those are the conditions in which we want F to be 1. So M1 should be 1. So basically in all these conditions, in all these first conditions where M1 is 0, our F is just going to be 0, right? So we can just write that. So it's going to be 0 0 0 0 0 0 0. Okay, so it's going to be 0 till here at least. That's fairly straightforward. And then what we want is M2 to be 0, but M3 and M4 to be the same. So if M2 is if M2 is 1, then we have zeros, isn't it? So we can just write 0 0 0 and 0. And then in this case, there's only 1 1 here because M3 and M4 are the same here. I've forgotten one condition here, which is 1 0 0 0. So I need to put that in. So don't make that mistake in your exam, forget some conditions. right? So that condition needed to be there, but I had not put it in. So that's going to be 1 as well. And this is going to be 0 and 0. Okay, and lastly, it's also said the function must also be done when all muscles are activated. And it says this condition overrides all the above. So which means that we don't have a 0 in the last condition when all muscles are activated, but a 1 here. And so that gives us our truth table. Okay. Now what we want to do is we want to do a K-map reduction of from here. So to draw a K-map, this is a 4 input K-map. So what we do is we need 4 columns and 4 rows. So we do this one. There you go. So, and let's say we put M1 and M2 on the horizontal axis and M3 and M4 in the vertical one. Just write the combinations. Remember 1 1 comes before 1 0. Okay, and if you fill this table up, you get, what do we get? So when M1 is 0, M1 M, so you have 0 0 0 0, and then you have again here M1 is 0, so all zeros, and then we have a 1 0 0 1, and we have 0 0 0 1. So that's our K-map, and we want to reduce it. And to reduce it, remember we have to make groups of these ones, right? So let's make groups. So one group that we can have is this one, and this one cannot be grouped with anybody. So there will be 2 terms in the expression, one corresponding to our term here, and another corresponding to this one. So what's the term corresponding to, let's say, this group? It's going to be M4 M3, because you can see that M3 and M4 are taking 1 and 1 values. M2 is not going to appear because it is taking the value 1 and 0, so M2 is eliminated, and M1 also takes the value M1, not M1 bar, because it's taking the value 1 here, right? And what about this term then? So we add this and say that term is going to be M4 bar, M3 bar, M2 bar, and M1, right? So that is going to be our function f. And now what we want to do is we want to implement this function using 2 input AND gates. So our f, let's just write it again very quickly, is M4 M3 M1 plus M4 bar M3 bar M2 bar M1. Okay, so to implement that, what we'll do is we want to implement this term first, so we'll need 2 AND gates like this, right? So M4 M3 M1, and at the output we get M4 and M3 M1. So that's our output here. And to implement this, what we'll do is we'll AND these 2 terms, we'll AND these 2 terms, and then we'll AND these 2 terms. Okay, so here's what we want to do: 2 AND gates like this, and then 1 more AND gate here, this way. Okay, so we do M4 bar, M3 bar, and then we say M2 bar, M1, and that's our expression, and both of these are odd, so you put it at an OR gate, and so this is your function f. So that's problem 2.